You ever stop and think about what's really keeping you safe online? You know, behind the scenes. Well, today we're going to pull back the curtain on one of the most important but totally invisible pieces of web security out there. We're talking about HSTS.
Okay, so let's start with a scene we've all been in, right? You're at the airport, you've got a couple of hours to kill, and that free airport Wi-Fi network is just calling your name. So you connect, you open up your browser, maybe go to check your bank balance real quick. Seems totally harmless, doesn't it? But what if I told you that simple act could expose absolutely everything?
See, the real danger on public networks isn't just someone peeking over your shoulder. No, it's a way more clever attack, one that's built to be completely invisible. An attacker can literally hijack your connection, turning what you think is a secure private session into an open book. Let's walk through how they do it. It's called an SSL stripping attack. So here's the play-by-play. You try to go to your bank's website. An attacker who's just chilling on that same Wi-Fi network snags your request before it even gets out to the internet. Then they make a secure connection to your bank, but, and here's the evil part, they serve a fake, insecure version of the site back to you. They have just become the man in the middle of your conversation. And this is what makes it so terrifyingly sneaky. To you, everything looks fine. The website works, you can click around. You probably wouldn't even notice that the little padlock icon is missing from your address bar. But what's really happening is that an attacker is reading everything you type in real time. Your username, your password, all of it.
So, how in the world do you fight an attack you can't even see? Well, this is where the web's architects came up with a really elegant solution. It's a direct, non-negotiable instruction that just takes the choice away from the attacker. It's called HTST.
HSTS stands for HTTP Strict Transport Security. And really, it's just a command that a website server gives to your browser. It's a simple but incredibly powerful rule that basically says, hey, from now on, you are forbidden from ever talking to me over an insecure connection. It's HTTPS or nothing.
I love this analogy. It's like the website is telling your browser, listen, forget that flimsy, unlocked front door, HTTP, even exists. From this moment forward, you only use the armored secure vault entrance, period.
So how does a website make this promise to your browser? It's not magic, not at all. It's just a single line of code sent silently in the background every time you connect securely. And this is it. This is the literal instruction your browser gets. It's called an HTTP header. And yeah, I know, it looks a little technical, but trust me, it's actually a really clear set of commands. Let's break it down real quick. Let's start with this massive number, 31,536,000. Any ideas? It's not random, I promise. It's a very, very specific length of time. It's the exact number of seconds in 1 year. This part of the command, the max age, is telling your browser, hey, I need you to remember this security rule for 1 full year. And every time you visit that site again, that 1-year clock gets reset.
So, max age sets the timer on this security promise. But what about that other part, include subdomains? That's just as important. It tells the browser, by the way, this rule doesn't just apply to the main website, but to every single part of it. You know, like login.example.com or shop.example.com. It protects the whole family.
Okay, so this sounds like a pretty perfect system, right? The website tells your browser to be secure, and the browser listens. But there's a catch. A single, tiny, but critical moment of weakness that attackers learned how to exploit. So let's go back to our airport story for a second. Let's say your bank does use HTSTS. Does that mean that SSL stripping attack is impossible now? Are you totally safe on that public Wi-Fi?
The answer, unfortunately, is no. Not on the very first time your browser has ever been to that site. See, the system has this little quirk called trust on first use. Your browser can't follow the HTSS rule until it's actually received the rule at least once. This timeline lays it out perfectly. On that very first visit, your browser is flying blind. It doesn't know about the HTST policy yet, so an attacker can jump in and strip the security. But once you've made just one successful secure connection, boom, your browser gets the instruction and locks it in. From that moment on, for the next year, it will automatically force a secure connection, shutting that attacker out completely. Now, that first visit problem is a pretty serious loophole. So how do you protect someone who's never been to a site before? The solution was, well, it was brilliant. They just decided to give the browser the list of secure sites ahead of time.
And that brings us to the HTST preload list. This is a massive, shared list of websites that are known to require secure connections, and it's literally built right into the software of your browser, whether you're using Chrome, Firefox, Edge, you name it.
Think of it like this. Instead of your browser having to learn which houses have armored doors, it shows up on day one with a pre-printed guidebook. For any site on that list, your browser won't even try to make an insecure connection, not even on the very first visit. It knows from the get-go that it has to be HTTPS. It completely closes that first visit loophole.
So let's bring this all home. When a server sends that HTST header and the website is on the preload list, what you get is this powerful layered defense system. It's a bodyguard that protects you without you even knowing it's there.
This table just sums it all up so nicely. If there's no HSTS, your risk is high. Simple as that. With HSTS but no preloading, your risk is medium. You've still got that first visit vulnerability. But when you combine HSTS with preloading, your risk level drops to low. You are protected right from the very start.
And really, that's the bottom line. HTTS is your personal invisible bodyguard online. It's working silently in the background, constantly upgrading your connections to be secure and just slamming the door shut on those man-in-the-middle attacks before they even have a chance to start.
It's a pretty amazing part of the internet's security fabric, operating completely out of sight. Which kind of leaves you with a final thought, right? If this powerful protection is happening without us even noticing, what other invisible systems are working every single day to make the web a safer place than we think?